Timberlake's Basic Chemistry, and we're in section 6.3, which is naming and writing ionic formulas. Remember, an ion is charges. So you have a positive ion where electrons have been taken and it becomes positive, and then you have a negative ion where you have gained electrons and it's negative. Positive and negatives attract each other. The attraction is just an electric charge. It's just a basic electrical force, and that's called a bond in this case. Okay, there's other bonds, but an electric bond is ionic. So when you have two ions, we're going to learn how to write them and name them. Okay, so first of all, you have to know that the positive ion, okay, that's the cation, C-A-T-I-O-N, the positive ion is first, and you just name it with its periodic table name. Okay, so if it's carbon, say carbon. If it's lithium, say lithium. So that first part of a compound, there's always two parts. There's a two-part name. It's a binary compound, two parts. So the first part is always your positive ion. Your second ion is second in the name, and you will change the ending of your second one to IDE. So if you had sodium and chlorine, it would be sodium chloride. That's how you would name a compound. So let's look at some of these. Okay, what would you call barium with 2 plus? Okay, is it the positive or the negative? If it's the positive, it goes first, and you would just call it barium. Okay, what about aluminum 3 plus? It's a 3 plus, so it's going to go first, and you would call it aluminum. Okay, what about K plus? It's a plus, so you just call it potassium. All right, how about nitrogen? It's a 3 minus, so that means it goes second, and you have to use an ending. What would you call it? Nitride. Okay, that's nitride. What about oxygen? It's a -2, so it goes second, and you have to change its name to oxide. How about fluorine? It's a negative. You would call it fluoride. Okay, how about phosphorus? Phosphide. How about sulfur? Sulfide. How about chlorine? Chloride. Okay, so if it's a positive, you just call it by its element name. If it's a negative, it ends with IDE and it comes second in the compound. Okay, so here's some examples. Sodium and chlorine is sodium chloride. All right, the formula has it together, but the ions there's positives and negatives. They are together, and they simply are attracted together electrically. All right, potassium and sulfur is potassium sulfide. Magnesium and oxygen, magnesium oxide. Calcium and iodine, calcium iodide. And aluminum and oxygen, aluminum oxide. Okay, so the only weird thing is that you have to know how to name the anion, or the negatively charged ion. Okay, so here's some ionic compounds. Potassium and iodine. Now, if you just had I, you'd call it iodine. But if you have I negative, that is the iodide ion. So the ion is named iodide, and so when you put it together, it's potassium iodide. So it's not just when you put it in the name, the anion itself has a change of name. So you have the bromide ion, or you have the oxide ion. So oxide ion is not the same as oxygen. Okay, because the charge is different, it behaves differently. And in this case, it beautifully joins up with positives. Okay, so you simply call oxide ion, add it with aluminum, aluminum oxide. So write the formulas and names for the compounds of the following ions. All right, you have sodium and bromide, so you'd call it sodium bromide. And what would its formula be? Please write these in your notes. It's 1 positive, 1 negative, so you simply have to combine them, NaBr. Okay. What about aluminum and bromide? Okay. You have 3 pluses. How many bromides do you need in order to balance 3 pluses? Do you see? Because every compound will be neutral. So it's AlBr3. Okay, and that's a subscript, not a superscript. So it's AlBr 3 lower than the R. Okay, sodium and sulfide. Okay, sulfide is -2. How many positive ones do I need in order to balance with a -2? I need 2. So the name is sodium sulfide, and what's the formula? Na2 subscript S. Okay. What about sodium and nitride? Okay. I've got 3 negatives and 1 positive. How many positives do I need to balance with 3 negatives? I have to have 3. So your name would be sodium nitride, but your formula would be Na3N. Okay. And the last two, aluminum and sulfur. Let's do the other one first because it's easier. Let's do aluminum and nitride. It's 3 and 3. That's a 1-to-1 relationship, so it's just going to be ALN, aluminum nitride. Now, the hard one is aluminum and sulfur because I've got a 3 positive and a 2 negative. So I can't say that how many 2 negatives go into a 3 and how many 3s go into a 2. It just doesn't work. So you are going to have to do a common multiple between 2 and 3. So a common multiple is a 6. So I think how many aluminums fit in 6? 2, because 2 times 3 is positive 6. How many sulfides fit in 6? Would be 3, because 3 times 2 is 6. So it's going to be Al2S3. Al2S3. That's hard. So you can email me if you are completely flummoxed on that one. Write the names of the following compounds. CaO, calcium oxide. Okay. KBr, potassium bromide. Al2O3. Okay. Do you see you don't even need to bother with the 2s and 3s. Just look, first one's aluminum, second one's oxygen, so it's aluminum oxide. So it's easy going from the formula to the name, harder to go from the name to the formula. And the last one, magnesium chloride. Okay. So the transitional metals, anything in the valley, say from scandium to zinc and under, and then all the way under the stairs, can perform more than one oxidation number. So it can have, say, copper can be copper 1 with a positive 1 charge, or it can be copper 2. You're going to see that all of those transition metals can have more than 1 charge. Okay, so it's not like the representative metals, or representative elements like group 1 and 2, and then the last 6, the ones that form valence shells. Those are easy. The ones in transition, you really don't know. They can form multiples. Now, you don't have to memorize which multiples they are. You just have to know that if it is 2+, then it's called iron 2. And if it's 3+, it's called iron 3. You actually name it according to the number of a charge. It's kind of a George Washington's white horse. So at the top it says most transition metals and group 4 metals. Group 4 metals would be, anything that's under the stairs. Okay, form 2 or more positive ions. There's 3 exceptions to this. Zinc is always Zn2+. Cadmium, which is right under zinc, so this is in group 10 or 10B in the valley, the very last one of the valley is zinc, and right under zinc is cadmium. It only forms 1, which is positive 2, and then beside cadmium to the left is silver, and it is only 1. So you do not say zinc 2, silver 1, or cadmium 2. Those you just say zinc. You say zinc something or silver something or cadmium something. Those are exceptions. All the other ones, you would have to use a Roman numeral when you're naming them, and you name the Roman numeral based on the charge. So if the charge is a 2+, you call it copper 2. If it's a 3+, you call it iron 3. And that's how you do it. Okay, so let's look at this. Chromium has 2, a positive 2, and a positive 3. So you cause the positive 2, call it chromium 2. Now notice that the name has a parentheses with no space and then a Roman numeral inside. So it's chromium 2, chromium 3. That's the name. Okay, you can't have one name for two different objects. So if chromium forms a 2 and chromium also forms a 3, you have to have a name for both of them, so you name it based on its charge. Chromium 2 is positive 2, chromium 3 is positive 3. And these are all the transition metals with the exception of zinc, cadmium, and silver. Cobalt is a 2 and a 3, so you call it cobalt 2, cobalt 3, and I'll just let you look at the other ones. There's numerous of these. Okay, most of these will form more than one possible charge. So here is the typical ions. Now the ones on the edges you can guess. Anything in group 1 is going to be positive 1, anything in group 2 is positive 2, anything in group 7 is negative 1, anything in group 6 is negative 2, anything in group 5 is negative 3. Then just know that any of the ones in the valley and under the stairs can have multiples, with 3 exceptions: zinc, cadmium, and silver. Those aren't named with Roman numerals. All the other ones are. Okay, sorry for your luck. So with 2 different ions to use a Roman numeral after the name to indicate the ionic charge. So Fe2, now let's look at this first one. Compound chlorine is in group 7. So FeCl2, if you look at this one, the first one on the list. Chlorine is in group 7. That means it's negative 1. If I have 2 negative 1s, and iron will make it neutral, how many positives do I need to balance with 2 negatives? I need 2 positives. That means it has to be iron 2. Okay? Now, here's the hard one again. I've got a 2 and a 3. That means that it has to be 6. Okay? Oxygen's in group 6, or group 6. That means it becomes negative 2 because it's 2 away from 8. 3 times 2 is 6. That means 2 times what is the iron? Okay, if the oxide ion is negative 2 and I needed 3 of them to make 6, then I need 2 iron what's to make 6? I need 2 iron 3s. Okay, so that's the hard example. Here's an easy one. Phosphorus, okay, phosphorus is negative 3 and I have 3 coppers. So what is it going to be? I need 3 1s to balance with a negative 3, so it has to be a copper 1. All right? The only ones that don't play this game are zinc, silver, and cadmium. All the rest of them have to be named with Roman numerals. Select the correct name for each. Okay? Well, iron is one in the valley. And so we need to know if it's iron 2 or iron 3. It's not going to be iron sulfide because they form more than one. So you're going to have a Roman numeral all the time in these, with the exception of zinc, silver, and cadmium. So it's either going to be 2 or 3. I need to find out what. Sulfur is in group 6. So what's its charge? Negative 2, because it's 2 away from 8. And I've got the 2 and 3, so I must need the multiple thing. So I have 3 times 2 is 6. Okay, the sulfur is 3 times 2 is 6. That means the iron is also 6. 2 times what is 6? 3. So it has to be iron 3 sulfide. Okay, how about copper oxide? Well, it's a 1-to-1, isn't it? Well, oxygen is in group 6. What's its charge? Negative 2. And this balances with it. That means that the copper has to be copper 2 oxide. If it balances with a negative 2, it's copper 2. Okay? Finally, select the correct formula for each of the following. Copper 1 nitride. All right, nitrogen's in group 5. Means it's negative 3. How many positive 1s? Okay? All right, if it's Cu3n, then that would be positive 1. Okay, so it has to be 3. And lead 4 oxide. Okay, oxygen is negative 2, and I know that lead 4 is what charge? This is the George Washington's white horse. Lead 4 is positive 4. So how many negative 2's do I need to balance with a positive 4? I need 2 negative 2's. So this would be 1, PbO2, lead 4 oxide. Okay? Headache, headache. I wish I were there. I'd give you, I don't know, some candy. So I miss you.